This is the back of 7.2 notes. We're going to introduce something called Radian Measure. Be ready. This is important. How many times have we written this on notes? Never. So it's very, very important for the rest of your life. Okay, just as segments and lines can be measured using inches or centimeters, those are two different units, and you guys are well aware of unit conversion, right? Angles also have a second unit of measure, and that's called, well, just watch. We can measure angles in degrees, which you've been doing since elementary school. You can also measure angles in radians. Say radian. Radians, okay? Radian measure is based on something called the unit circle. The unit circle is going to be so important for your math life for the next few months, okay? By definition, well, tell me, what does the prefix uni mean? It means 1. So by definition, the unit circle is any circle or a circle with a radius of 1. So the unit circle has a radius of 1. If a circle has a radius of 3, it's not a unit circle, okay? So we're going to derive where radians come from. First, find the circumference of the unit circle. Do you guys remember the circumference formula? Yeah, we took a quiz on it. Pi r squared is area, pi times diameter, or 2 pi r, because diameter is 2 times r. All right, but what's the radius of the unit circle? From here to here is what? 1. We wrote it right there. Radius is equal to 1. So r, the circumference of the unit circle, is 2 pi times 1, which is just what? 2 pi. Okay, so what this means is 360 degrees is equal, so this is in degree measure, that's equal to 2 pi in radian measure. Just like miles and feet. Do you guys know how many feet are in 1 mile? Neither. 5,000 something. I don't know it by heart, okay? How many degrees are there in 2 pi? 360. Okay. You ready? Here we go. So all the way around the circle, instead of 360, or it's 360 in degrees, but in radian measure, it's 2 pi. This is really important, so you got to watch this. So if all the way around this unit circle is 2 pi, what would halfway be? What would 180 degrees be in radian measure? All the way around is 2 pi. So this halfway would be 1 pi. Very good. Okay. So pi is equal to 180 degrees. Oh, let's write that right here. 180 degrees is equal to pi. Okay, watch my pen. From 0 degrees to 180 degrees is equal to pi. So what would from 0 to 90 degrees be? Half a pi, right? We're going to write that as pi over 2. That's half a pi. So 90 degrees is equal to pi over 2. Can anyone come up with what 270 degrees is down here? Okay, so it's pi plus a half. So it's 1 1/2. How can we write that as an improper fraction? So we're going to write that as 3 pi over 2. That's 1 1/2. Okay, what would, ready? If this is 90 degrees, if 90 degrees is pi over 2, watch this. What would 45 degrees equal? Pi over 4 is correct. Good job. I didn't write down 270. So 270 is 3 pi over 2. 45 degrees we said was a fourth of pi. All right, that's a good introduction. You ready? Now, in science, do you convert units a lot? Yes? Or we did it in middle school, freshman, sophomore year maybe. So now we're going to learn how to convert from degree to radian and radian to degree, and that's what we're going to practice for a while, okay? So to convert from degree measure into radian measure, we're going to take our degrees, and we're going to multiply by a conversion factor, pi over 180. And the degrees will cancel, and we'll get our radians. And then to go from radian measure to degree, we'll flip it. We'll do the reciprocal. We'll take our radians and we'll multiply by 180 over pi. Our radians are going to be, we got to write this. We got to write something in here. Ready? Left as a reduced fraction with pi. So you're going to leave pi in all your answers. We're not going to multiply it by 3.14. Left as a reduced fraction with pi. Do you know what IE stands for? Like, for example, 5 pi over 7, 11 pi over 3, like that, okay? The degree, however, we'll leave as a whole number or decimal. So decimal, or a whole number. We'll multiply it all out and divide it. Oh, the pi's are going to cancel. Okay, don't worry, we're going to look at all these with examples. Let's see, anything else I wanted to say about this? Okay, one thing I'm going to say out loud. Ready? Listen. There is no unit abbreviation for radians. So do you know what's a unit for degrees, or the symbol? That little circle, that tells you it's degrees, right? What about inches? What's the abbreviation for inches? What about minutes? MIN. Okay, radians. There's no unit abbreviation, so how do you know it's radians? It will usually be a fraction with pi, okay? There's no unit abbreviation for radians, but it's usually a fraction with pi. Okay, we don't write rad, we don't do any of that. You ready? Here we go. Let's do some examples. Convert from radian to degree or degree to radian. What are we starting with here? 90 degrees. We want the degrees to cancel. So watch. I don't use this ever. Ready? If I want the degrees to cancel, where do the degrees need to go? In the denominator. Because I want the degrees to cancel and be left with radian. Okay, we're going to reduce this fraction. So what's 90 over 180 reduced? How do you reduce what's 90 over 180? Hi, 9, cross off the zeros, 9 over 18 is what fraction? 1/2. Didn't we already know the answer to 90 degrees is pi over 2? Yep. Okay. Hey, if it's negative, you don't change it to positive, you just keep going. You just reduce it. So, negative 235 degrees over times pi over 180 equals, oh, I'm going to show you a cool trick that you may have never known in the calculator. It's called a fraction button. Have you ever used a fraction button? Okay, so we all should be able to reduce fractions. Like you could divide by 5, right? We know 5 goes into both of these. But I got to show you this cool trick because I don't want you to get any older than you are without knowing it. So watch, 237, but not 237. We're going to do the actual number 235. Find a button on your calculator that looks like a fraction. Do you see it? Do you see this ABC button here? Okay, click that. And then put in 180. What about the pi? Don't worry about the pi. Don't type it in either. Sorry, so it should look like that. 235, ABC, 180, and hit equals. All right, don't worry. ABC, 180. Okay, then you got something that looks like this. All right, we don't want that. So you're going to hit second fraction button, enter. Second fraction button, enter. Do you see that? 47 over 36. If you have a Casio or a different one, it does it way better. It's much easier. You don't have to do all this work. So this answer is 47 pi over 36. Let's keep going. We just changed degrees into radians. This is it. This is an ugly radian over there for B. Now for C, is this starting in degrees or radians? It's starting in radians. How do you know? It's a fraction with pi. Okay, so look up here. To convert from radian to degree measure, what are we going to multiply by? Okay, so ready? 180 over pi. We want the pi's to cancel, and we want to be left with degrees. Okay, do you see the pi's cancel? Yes? So they divide out. And then if you want in the calculator, but a lot of these are going to be easy to do in your head, but you could do 2 times 180 divided by 3. 2 times 180 divided by 3. And what do we get? 120 degrees, like that. All right. What do you do if it's negative? Do you start crying? Do you freak out? No, you just leave it negative. All right. So for D, the pi's cancel. Hiya, karate chop. Pi divided by pi is 1. And then how do we do this? We're going to do 13 times 180 divided by what? 6. And we get negative 390. All right, we have some bad English here, so we can you can correct all the mistakes. Ready? First converting, what should we first what? Convert the given angle into degrees. Ready? Here we go. Do you want the pi in your answer? No. So where are you going to put the pi to cancel it? On the bottom. And what's going to go on top? 180. What do you do with the pi's? Cancel. And then negative 4 times 180 in the calculator divided by 3, or you could do it in your head. So we get negative 240. Okay, so we converted from radian to degree measure, then find one positive and one negative coterminal angle and draw them in standard position. How do you find coterminal angles? Add or subtract 360. So when we add 360 to 240, what do we get? Plus 360 in the calculator, 120. Good. Is that positive or negative? Okay, we need a negative one. So negative 240 minus 360. What's that going to be? I'm out of time. Negative 600, thank you. And then we're going to draw both of these angles in standard position. So I might run out of time. 0 degrees, I'm trying to get to 120. Going to go up, boop, 120. And then negative 600 would be around